Okay, I trust that you watched that video again if you needed to. Alright, we're going to do problem number 3. After I work a second one, then I'm going to ask you to work one on your own and see if you can get it. And if you're struggling, then you can watch my video again. Alright, so step number 1, and I'm going to try to follow the same steps I followed on the other side of this paper, was write out what was given. So I'm given cosine of theta equals 2/5. Then step 2 was apply a reciprocal identity. So the reciprocal of cosine, if you look at your chart of formulas, is secant, and you just flip this upside down. So now we have secant and we have cosine. Okay. Step number 3 was figure out the correct quadrant so that we can get the signs right on all the others. Okay. So cosine is positive, so that means it's either going to be in the first quadrant or the fourth quadrant, because cosine is the x and the x is positive here. Cotangent is positive in the first quadrant and in the third quadrant. So the only place where both of these happen is in quadrant 1. In quadrant 1, everything is positive. So all of my answers, I'm going to choose the positive one. Okay, that was step 3. Step 4, and you can do them out of order. You can actually do that step first. Step 4 said, apply a Pythagorean identity. Well, I really always like to use sine squared plus cosine squared equals 1 because it is the most common known Pythagorean identity. So, let's fill in. I don't know sine, but I do know cosine. And make sure you put your little 2's in the right place. It's the sine that's getting squared, not the angle. Okay, so I square 2 over 5 and I get 4/25. Sine squared theta plus 4/25 equals 1. I got that because 2 times 2 is 4 and 5 times 5 is 25. Throw it over to the other side. I know that 1 is 25 25s, 25 25ths. So when I throw 4 over to the other side, I'm going to have 21 25ths. Because I'm subtracting. I take the square root of both sides, and I don't need the negative one because it's in quadrant 1 and everything is positive. So this is going to be the square root of 21 over 25. Well, 21 is 3 times 7. It won't break. But 25 breaks into 5 times 5. So the sine of theta equals the square root of 21 over 5. And now I have found 1, 2, 3 of my 6. So the 5th step was to apply a reciprocal. So the reciprocal of sine is cosecant. So I'm going to flip that. I cannot leave a square root of 21 in the denominator, so I fancy 1. And the cosecant is 5 on the square root of 21 over 21. So now I have found 4. 1, 2, 3, 4. Now at this point, I said you could use a reciprocal identity or you could use a Pythagorean identity. Last time I did it, I did a reciprocal. Oh, right here. Last time I did a quotient. I used sine over cosine. Well, this time I'm going to use another Pythagorean identity. I know cosine, secant, sine, and cosecant. I know cosine and secant, sine and cosecant. So what do I still need? I still need tangent and cotangent. So I pick a Pythagorean identity that has one of those in it, and the one that I'm going to use is tangent squared plus 1 equals secant squared. Okay. Tangent squared plus 1 equals secant squared. I don't know tangent, but I do know secant. 5 over 2. So let's square 5 over 2, and that's going to give me 25 over 4. I'm going to move the 1 to the other side, and when I do, it's really 4/4. I'm going to get tangent squared theta equals 21/4. I take the square root of the top and the bottom, and remember this time I only need the positive one, so the square root of 21 over 2. Now that's one way of getting it, but suppose you don't like that way and you want to use the quotient identity, sine over cosine. So I find sine and I write it down, and I find cosine and I write it down, and I do same, change, flip. The 5s are going to cancel, and because our God is a God of order, I'm going to get the square root of 21 over 2, which is the same thing I got before. Now I've gotten 5 of the 6. All I need is cotangent. Once I've got tangent, to get cotangent, I'd simply flip it. I can't leave a square root of 21 in the bottom, so I fancy 1, and I get 2 on the square root of 21 over 21, and that is cotangent. All 6 of them are positive because it was in the first quadrant. Okay. So I have found all 6: cosine secant, sine cosecant, tangent cotangent. And that's problem number 3. Okay. I would like you now on your own to try for me problem number 4. Figure out what quadrant it's in and work all 6 of them out for me on problem 4, and then come back to the next video.